Number 38, complete and balance each of the following half reactions, which are steps 2 through 5 in our half reaction method. And in this case, in letter D, we have to balance H2, which is a gas, and that's going to go to H2O, which is a liquid. And they wanted us to balance it in a basic solution. So in this case, I wrote down all the steps for you guys. We're ultimately going down here because we need to balance it in a basic solution. However, if we do look at the first criteria to balance a basic solution, we got to get the acidic answer first. So that's the annoying part of basic solutions. You still got to do this to get to the basic answer. So now I'm going back to what we've been doing, right? And that's the steps 2 through 5. Okay. So we got to get the acidic answer first. Now, we don't have to do the first step because the first step in a full-blown balanced redox reaction is to break it into your half reaction. However, they told us that we're working with half reactions, so I don't have to do anything here. They did it for us. But now we got to do the work. So let's see. The second step is to always balance all elements except hydrogen and oxygen. So I'm looking for all elements that are not hydrogen and that are not oxygen. I'm looking at my reaction and I only see hydrogens, right? Here's a hydrogen and here's a hydrogen, and I'm only seeing oxygens. There's no other elements besides those. So I'm skipping over the second step. There are no other elements except those, so I don't do that step. Now the third step is always to balance the oxygen by adding H2O. Now here's a quick tip. If you need to add one oxygen, you will add one H2O because there's only one oxygen in H2O. However, if you need to, balance or add two oxygens, you'll add two H2Os. If you need to do three oxygens, you'll add three H2Os. So just know that little trick, I guess, right? So let's see. On my left side, I have no oxygens, okay? But on my right side, I see that I have an oxygen. How many? I have one, right? So if I have one on this side, I need to add one oxygen on this side, but I can only add oxygen by adding H2O. So if I only need one oxygen, I need to add one H2O. Okay. Now my oxygens are balanced. I have one oxygen and I have one oxygen. So we're good. Okay, so this step is done. We're moving. The next step is to balance H by adding H+. So here's the same thing again. If you need to add one hydrogen, you will add one H+. So the same thing here. If you need two hydrogens, you need to add two H+, three hydrogens, three H+, etc., etc. Let's tally up the total number of hydrogen on my left side. Well, I have a hydrogen here. I have a hydrogen here, right? And how many? I have two, right? I have two of them. Plus, I have hydrogen here. How many? Two, right? So I have, and if I can, I have two hydrogens from here, plus I have two hydrogens from here. So I have a total of 4 hydrogen on my left side. And now let's look at my product side. I have a hydrogen here, and I have 2 of them. So I have a total of 2 hydrogens on my product side. I have a total of 4 hydrogens on my reactant side. So it looks like I have to add my hydrogens here, right? And so plus H plus. How many? Well, I have 2. I want to get to 4, so I have to add 2 more. So I have to add 2 H pluses. And that gets rid of the hydrogen problem. Perfect. Okie dokie. And now comes the fun part. We have to balance the charges. We balance the charges by adding electrons. And electrons are E negative. Electrons are negative, so they need that negative charge. And we always add the electrons to the more positive side. Now the question is, which side is more positive? So I like to make a divider, just so I can get things clear in my mind. But I have to find the total charge of the left, and I have to find the total charge of the right. You only need to look in the upper right-hand corner of the molecules or the compounds that they give you. You don't need to find the individual charges for H and O. For H2O, I'm only looking in the upper right-hand corner. Was there a charge here? No, right? You see how in H plus there literally is a charge here? There's no charge here. So it's not positive nor negative. It's neutral. It's a zero charge. So I have a 0 coming in for hydrogen. I have a 0 charge coming in with H2O. And the same thing here, right? I look in the upper right-hand corner. I don't see a charge for H2, so that's a 0 charge. So that's 0. And since these are being added together, I add my numbers together. 0 plus 0 is an overall 0 charge. So I have an overall 0 charge on my reactant side. Now I just got to find the charge for my product side. But here's water again. I'm looking it up, right? And I see that it has a 0 charge. So that's a 0. But now here I have a plus 2. Well, I just gave you the answer, but that's okay. You see how here I have a plus 1, right? If you just see a plus, it means that it's a plus 1 charge, but you have 2 H pluses. So you have to multiply these numbers. So 2 times a plus 1 is a plus 2. And now you add those two values together. 0 plus a positive 2, aka 0 plus 2, is a plus 2. I like to just put the positives because in chemistry, usually you'll always see it as a plus 2 charge, meaning positive. You won't just see like a 2. So that's just a habit for me. So now we always add our electrons to the more positive side out of the 2. Which has a higher number? Oh yeah, definitely the plus 2. So I know that I have to add electrons here, right? But now the question is, how many electrons? 1 electron? 2? 3? The answer is always the higher number. You want to go down to the more lower number, the more negative number. So how many numbers is between a plus 2 and a 0, right? How many bunny hops would I go from a plus 2 to a 0? 2. So that's how many electrons that I have to add. Okay, so now in this case, this one is a special case because I see that I have the same compound on both sides, right? I see that I have a water on the left side, and I see that I have a water on my product side. So what I can do is I can actually just get rid of the waters. If you do see that you have the same compound, you have to simplify, okay? So in this case, both of the waters would go bye-bye. I have 1 water on the left-hand side, that goes bye-bye. I have 1 water on the product side, that goes bye-bye. So what I'm going to do is I'm just going to simplify this. I don't need the charges anymore, so I'm just getting rid of it. Just so that it doesn't look like a hot mess over here. Okay. And now I'm just going to bring this closer. So now this is the acidic answer. If they asked for a acidic answer, and maybe I could just get rid of this because we don't need that anymore. Your acidic answer would be H2 gas yields 2H plus 2 electrons. But now they wanted basic. So now I just make sure that I have the most simplified acidic answer, which we did. So we already got rid of step number 1. And we just did this one, so I'll check that off. Now, here comes the quick things that you have to do for your basic solutions. The next thing is you're going to add as many OH minuses, so hydroxide, as you have H pluses, but you got to be fair. You got to add it to both sides. So you look on the left and you look on the right and you see where's that H plus that I added. Oh, it's over here. You add as many OH minuses as you have H pluses. So since I have 2 H pluses, I'm going to just add 2 OH minuses. But you got to be fair, you got to do it to both sides. So if you add 2 OH minuses here, I will say plus 2 OH minus here. So that's that. And now last but not least, all you got to do is just simplify. there's one big thing that you have to know, right? We want to cancel out the like waters, but just know, and I will put it maybe up top here. Remember that H plus OH minus yields H2O. So when you have these two, hydronium and hydroxide, coming together, you will always cancel these out and write them as their water components. And just know that for stoichiometry, you have one H plus, one OH minus, and that will make one water. So if you have two H pluses, you have two OH minuses, that will make you two waters. And that's what we have here. I have two H pluses plus two OH minuses. Scratch that. I'm going to write it as two H2Os. So I'm just going to erase this. Scribble, scribble, scribble. And I'll say 2 H2O. Now let's see, do I have any of the same compounds or molecules on the left and the right side? No, I have OHs on this side. I don't have any OHs anymore. I have water on this side. I don't have water anymore. So I'm done. I don't have to simplify. I can't simplify. This is the most simplified form. And now you guys are all good. So the answer would be 2OH minus plus H2 gas yields 2 H2O plus 2 electrons. And that's it. A lot of 2's here. But I can't simplify that anymore because I only had one H2. So as soon as you have like a 1 as your coefficient, you can't simplify that equation anymore. All right? So that's this one, guys. Hopefully this helped. Let me know in the comments what you thought. I hope you guys are doing awesome in your classes. Let's keep going. Let's keep, working hard. And if you guys are in physics or math, we also have videos for that as well. If you guys want to check those out, a lot of videos for you guys. I'll see you all in the next lesson and have an awesome day. Bye-bye.